Hello everyone, let's continue our series of tutorials of how to develop the robotic arm simulator. Last time we created the Unity project, imported the robot, configured regions with the Blender, and also I added these changes to the README file. If you also work with the GitHub repository, you can make it similar way, so you can write something. If you use this symbol, then it will be the new line here. For example, if I deleted it here, it will be the single line. If you add this symbol, it will be the new line. You can also preview it here. If you wanna add an image, you can simply drag and drop this image here. So once you finished with this README file, you can also commit these changes. And then as you made changes here, and then you need to pull everything in your local drive. Pull, check here. So then you will see updated README file here. So what we'll do for the part 2. First of all, I will show you briefly what we will have in the end of this tutorial. So the idea is to grab this cube based on the Matlab program. So we will work with the communication between Unity and Matlab. So we send some commands to the robot, and robot execute these commands. For example, let's see how it will look like. So I start project in Unity, then I will run the Matlab file, and we will see that robot moves. Here we will see animation of the gripper. So then we grab this cube and then we release it in the initial position. So that's what we will do in this tutorial. So let's move to our Unity project, and scene should be looks like this way. So we stopped here. Also here I added a floor creation, so I will show you how to make it here as well. So we will have a floor, not this area. So how to make that? Here we can simply copy the floor, Ctrl+C, Ctrl+V. Then we can adjust it in some places. So how to adjust it? We can hold V button on our keyboard, and then we can check a region here. So for example, we interested in this corner, so we drag and drop it here, and it will be adjusted. So next we can select two objects, also hold V button, change a region. Next we can select four objects, Ctrl+C, Ctrl+V, V button, we adjust them. And similar way for creating other space. So now we have the floor edited. Next, let's add them to a single game object, so we won't have this multiple floor object. So here we create empty object, we name it as floor, and drag and drop this all floor objects here. Now all floor objects are stored here, so we can disable them and activate, for example. Next, let's move to the gripper. So how can we grab the object? let's find the gripper. Here it is. If you wanna zoom into the particular object, you can click F button on the keyboard. Then you will be zoomed automatically here. Currently, let's copy this object and see how can we work with it. Just for testing purpose. Let's deactivate red and green cubes and work only with the blue one. I will locate this gripper above the cube, and also I will unpack this prefab. So I will add changes here and here. Next, what we need to do? We need to find objects which will touch our cube. So if we touch this cube, it will also move by these parts. So we need to add a collider object to these parts, these 4 parts, for interacting with the cube. Add component. Here we search for collider. Mesh collider, activate convex, and we will see. So these parts now highlighted in green, so these parts will interact with our cube. And this cube also has a collider. This cube. So it also, this green part is a collider. So when collider interact with each other, they can move each other. Next, what we will do is to also make the same changes here also for those gripper above. Also we need to add collider here. Mesh collider, convex. Next, how can we grab the object? First of all, we need to detect the object we work with. So how can we detect it? We can locate some object inside our gripper. For example, I can create 3D object, sphere. So by this sphere we can detect our object. So I locate it a bit above, and I will disable mesh renderer. So I will leave only this collider part, this green box here. And now if I will start the project, also currently I don't need animation, so I will currently disable it, and let's try to check what will be if I will try to move my gripper to the cube. Here I have my gripper. If I will move it to the cube, so now you can see that sides interact with our cube, and also the sphere should interact with the cube. So we don't wanna the sphere interact with our cube. So we need to add some settings here. So what we will control is how a sphere is entering this cube. For this we need to activate this is trigger settings. So this means that once this sphere is entering our cube, we can see how this variable is changing, is trigger. Next, let's move to the script creation, and here we will consider the collider test script. I will name it the same way, so I will create first of all the script folder, name it scripts, and create new script, name it as collider test. Wait till it will be opened. Now the script was opened, and here we create the several variables we will work with. First of all, public int variable, we name it as grep, and by default public. By default it will be equal to 2. So what it means, if we send command 0, as I remember, let's check here, 0 command is for release the object, 1 for grep, and 2 do nothing. Let's write this comment here. In order to do not forget, next we create public game object grep. No, we already created grep. So we create game object anim for working with the animation. Next we will work with the collider, so we need to create a variable collider, name it collided with. Next, when we start our game, by default we do not need animation. Here I disable it here, but we can also make it with the script. So what we need to write is anim.get component. We are interested in the animator component. Animator. Next, the component speed. If we adjust speed equal to 0, it means that animation is not active. If here will be 1, it means the animation plays forward. If we set -1, means that animation plays backward. Next we go to the update loop and write a program logic for the grep command. if grep equal to 1, we need to grab the object, and otherwise if grep equal to 0, we need to release the object from this logic. 0 release object, 1 grab to do nothing. So let's write two functions for it. How we can grab the object. So what's the logic for it? Let's save it first. Save, and we add it to our sphere, this test collider test. Next, we need to add animation file here, but first of all, let's run our game again and see what will be with the animation. Here, so we see that animation is working, and for example, we want to stop the animation in some particular place. Here we have an animation window. Let's see how it looks like. Here, for example, we can set up a preview, and next we can move this object and see how the animation changed. We want to stop our animation when we somewhere close to the cube, for example in this position, and this will correspond to the particular time. So here we have 2 seconds, 3 seconds, 4 seconds. So at this place we want to stop our animation, so we know that we somewhere in this region. So next we stopped here. Next we will check for whether our sphere is entered the cube or not. If yes, if we're inside this cube, then for moving this cube, where is it? Cube below. This cube below, it has the rigid body component. What does it mean? For example, if I will move this cube up, then it will drop out because it has a rigid body component. What can we do with this cube? For example, if we set is kinematic is true, then we can move it up. And if I will set is kinematic is false, then it will drop out. Also, we need to change transform of this object somehow. So how can we make that? For example, if I will change the parent object of this cube, and now if I will move the gripper, also I need to set this kinematic is true here. So now if I will move the gripper, the cube also will move. Next, for example, if we set command to release this object, sphere, cube blow. So if we want to release object, we set this kinematic to false, it will drop. So now let's program this logic. First of all, I will add animation file here. So now, as we already made some programming here, so by default, if we now start the program, we will get component animator, which corresponds to this game object, and this animation won't play, so speed will be equal to 0. So now if you start it, here it stopped. They worked. This one is working because we attached this gripper, but not this one. So this one we will use for testing, so we move this gripper here. So we work with this element, so here animation doesn't work. speed is equal to 0. Next, for working with time in Unity, we need to create coroutine IE numerator, and we name it as test coroutine. Next, here we need to call this coroutine somehow. So when we send command equal to 1, when we wanna grab our object, we will start this coroutine. So here we, in order to start the coroutine, we need to write start coroutine, and next we need to write name of the coroutine we wanna start. So we wanna start this particular coroutine. Next, once we enter the coroutine, we can reset our grab command. So we know already that it was 1, so we entered this coroutine, so we can now set grab object equal to 2 again. So we set grab equal to 2 once we inside this coroutine. Next, we need to activate our animation, so it will be equal to 1. And next we need to wait for some time, for 3.7 seconds. For this we need to write yield return. So now once I wrote return, before the coroutine was highlighted because coroutine need to return something. For example, we can wait for some time here, return time, and new wait for seconds, and we write for how many seconds do we need to wait. 3.7 seconds. After that we stop our animation. First of all, we run our animation. Once we waited for this time I explained before, we stop our animation. Next, we also need to write function for colliding with the object. Private void on trigger enter. Sorry. Next we write our object collided with equal to other, so we will know with which object we collided with. This script is attached to the sphere, so sphere will detect with which object we collided. For example, here we can print the name of the object as well. Print other, and we'll see name. In our case it will be printed blue. Next, here we need to, for this object, if we want to grab it, we need to disable a component is kinematic. Here write get component. Component we want to get rigid body. And next is kinematic equal to true. So we need to activate this kinematic in order to move the object. And also we need to change parent object of the cube. Again, our object collided with, we need to write transform parent and equal to this transform. This transform means that this script is attached to the gripper. So, this script is attached to the sphere. So sphere means this. So the cube will change parent to the sphere. So we finished with the grab object. Now let's write function for releasing the object. Private void release object. Here we write function. When we wanna release our object, again we need to work with the animation, but we wanna play our animation in a reverse order, because here when we grab our object, we play our animation forward. When we release our object, we need to play animation backward. Again, we need to first of all, animation get component animator. Here we need to select start playback. Start playback. Next, we set speed of animation equal to -1. Next, we unparent our component from the sphere. So we set parent equal to null. So again, this object won't be parent to any other object. And next we set is kinematic to false. So it will fall down. So we finished. Again, here we need to call the function. So here we finished. Let's try to check our script collider test in Unity. So by default it's equal to 2. Let's play with it. So here I will lock this window. So for example, now I will move this object, but also I want to change values of the grab variable. So now I can move the object, but I cannot change values. I need to go here, change, and then again go here. But I can click this lock here. Now I will be able to move the object and also change variables here. So for example, now I entered the cube, and here we see that it was printed cube blue, because here we displayed with which object we collided this with. If I try to enter it again, I will see I collided with cube blue. So once I collided with my object, I can here try to grab it. I need to write 1. We will see that animation has started. Once it's past 3.7 seconds, it stopped. Also, now we can see that parent object of the cube was changed, and also is kinematic is true now. So now if I will move my end effector with gripper up, I will see that cube also moves as well. So we grabbed the object. If I will write here 0, it will release my object. Let's try to write 0. We see that animation played backward and cube is fell down. So we use it for testing. We see now that it's working. So we can delete this demo object here and move everything to our a real gripper. Here we need to add first of all sphere object, move it a bit up, next also disable mesh renderer here. This one we can delete already, we don't need it any longer, or we can copy component. Now let's just delete and add again the script to this sphere. Collide the test here and animation object. Animation now is located here. Here you can just check the animation. For example, if you write one animation will start, it will wait for 3.7 seconds. It doesn't have the object collided with, so we can just simply write 0. It will go back, but we tested it before, so when we approach to the cube it should grab it. Next, let's set some script for manipulating with the robot joints. This script will be called as robot test. So we previously operated by these regions manually. So now we will change them through the script. So we will write the script for operating with this X rotation, for example, for this joint 3. So let's write the script which will be called robot test. This is our second script. Create a script, robot test. So here what we need to do is to create several objects. Game object J1. Here we will touch our link and the value for the angle itself. Let's write them to our script. First of all, public game object joint 1, public load joint 1 angle, and in the same way for other joints. Joint 2, joint 2 angle, next 3, here 3, next one will be 4, 5, 6, 4, 5, 6. So next we go to the update, and here we will change particular angles. For example, for joint 3, as we have seen before, we change the first rotation component here. joint 3, we change the first one. For example, for joint 4, it will be the last one. So that's why here in these scripts, which rotation object we change in, there we set 1. So this rotation object will be replaced with our angle. So I won't write it manually, so I will copy it from here. So if you will have any problems, you can check rotation object with these vectors. But if you made everything the same with the previous videos, it should work similar way. Let's save it. Go here, and here we create also empty object for our scripts. Let's name it scripts, and create empty object, call it as our first robot, robot1, and attach our script robot test here. Next we need to attach our joints here, and here we need to pay attention that for every joint rotation components should be equal to the 0. For example, here rotation component not equal to the 0, so we need to set it equal to the 0. We can create, for example, empty object. We can name it as joints. Next we try to attach all of our joints here, and we will see now that it has 0 now. So we should see the same transform components for your robot. So what we do next, we need to attach our objects here. Joint 1, joint 2, joint 3, joint 4, 5, and the effector. Now let's try to change rotation components of them. So currently again we can manipulate with them manually, and you should see the similar rotations. So everything works correct. So that's what the second part. So first of all we created collator test, next we created the robot test script, and next will be the third part. We will work with Matlab and with scripts. It will be the longest part of this video. So let's move to it. For this procedure we need to create the script called server, and here it consists of some network settings for manipulating with Matlab. I won't explain all of these things. I will explain just the part which will receive the data about this part. So this is the data we obtain from the Matlab and modify our robot respectively with the particular angles of particular joints. And also here you can see the command which will activate, deactivate our gripper. So probably I will just copy this script from this project. Control C. So this file I wanna copy to my scripts folder. And if you need these files separately, I will also place it to the description of the video. Next, let's create here another component which we'll call client object, and we'll attach this server script here. Port should be similar as will be in the MATLAB later, so let's, for example, set up this port and open this script. Check what we have here. First of all, we need to consider the MATLAB program. So for this repository, I will create also, first of all, we had the Unity project folder, but this time we will also have the MATLAB project. MATLAB project. So here we'll locate the MATLAB files. Let's move to the MATLAB. First of all, we need to install the robotic toolbox we'll work with. So I previously installed it, so now I will delete it and will show you how to install the robotics toolbox. Here's where the MATLAB was installed, and here I located the robotics toolbox. This one. So I will delete this one and I will show how to install it. Home. Let's try to close MATLAB. Try again. Why I cannot delete it? Okay, good, it was deleted. So now, how to install it? This robotics toolbox we will work with was developed by the Peter Quark. So if you will go to this GitHub page, link also will be in the description of this video. So you need to scroll down. Here you can see some beautiful things you can do by this toolbox, and also you can see this beautiful things. Car. Next we need to find the installation guide. So here you can see first edition, second edition. So we will download the second edition. So you'll see this MATLAB drive folder. Here you need to click and download shared folder and wait till it will be downloaded. so we need to wait for some time. So then the download will start, and then you need to wait till it will be finished, and you need to first of all unzip this file once the download will be finished. Let's wait a bit. Finished. So next we need to unzip it. Also wait a bit. So next we need to go here. So we are interested in this folder. So currently, if you will see that if I will try to start, for example, my program, here it's working with the robotics toolbox. It also has connection. Okay, I will, for example, start the Unity. Next, I will try to start these things. Okay. Here I need to change the folder first. Change folder. Then we will see that it has an unrecognized function variable revolute. So this function is included to the robotics toolbox. So first of all, we need to install this robotics toolbox. So how to make that? We need to find this folder and copy this folder to the Matlab folder. You need to find where you installed the Matlab, and next go to the toolbox folder and copy folder here. And wait some time. So it was copied, it's here. First of all, we need to copy this path and go to the home, next set path, add folder. This folder we need to add, select, save. Next we need to run on this startup RVC file. Editor, run. So it will install the robotics toolbox. Now if I will go again to the file which consists of some variables, some functions from this toolbox, and try to run it again. I will see now that it doesn't have this error any longer. So it doesn't have error, but currently it's not working with our simulator. So next let's continue to operate with it. First of all, let's consider the Matlab program. Here first of all it's clear some things. Set name, that it's Matlab, so it will display it in Unity who has connected to our simulator. Next, about these points, how to set up them. What do they mean? If I will just run this part of the script, we will see, just run this section. We will see our robot. So here we need to set up a length of every link similar to our simulator. So how to make that? We need to go to our simulator and for example create here game object which we'll call base region. Where is our base region? So it's here. It's not exactly here, so I will move it a bit manually. So let's locate our base region here. So I will reset this component 0, 0, 0, and I wanna set up a region for base in the right place. So I move it a bit down. If you need more precise region settings, you can do it with a blender, as was explained in the first video. Next, for every joints we wanna measure. Let's try to find the. I will try to find the document where these regions already shown. I had it somewhere. Wait a bit. Not this one. Robot data. So this file. So here you can see the robot settings for every link joint which are presented by the author of the developer of this robot, but we can also check them with Unity. So let's check them with the Unity. For example, first of all, we create empty object here, move it to our region, name it as J2. Next, this one, again create empty object here, name it as J3. Next, next this one, create empty J5. Next, for our end effector, let's rotate it. Not this one. But this one. And also leave it this way. And effector. So here again, need to shift the region of the end effector, create empty object. Can do it with a blender or can do it manually. EE. Next, region of the gripper. Example, same as the sphere. Create empty object here. Gripper. Next, we need to compare them with Matlab. So base origin here, and we compare everything with Matlab. So here you can see where is the joint number 2. We could reset them all to 0, so it would be more easy to check our regions. So align them with one origin. Let's try to make that it will be more easy to compare. So that coordinate equal to 0. 0. 0. 0. 0. So they still in the same place. Now let's check the values. For example, for this length should be equal to this value, 2, 3, 5, 8 if we round it. Next region, this one should be equal to this value, 0.3. We can write 319. Next one, this one, 0.735, and also we're interested in this offset. So here we're interested in two regions. Here we write minus 0.25, and next one is the end effector point, this value, or the gripper point, it's this value. So we can create variable, and whether we can approach with the end effector or with the gripper. So how these parameters were built, you can check the documentation of this toolbox, or you can read about DH parameters. Also some links I will leave in the description. So next, from this data we create the robot joints. Next, about the program itself. First of all, we created the serial link, joints. Next, grep equal to 2 means that we do nothing. Next, we need to show the origin of our blue cube. So these elements. Again, we created the base origin, so origin start from here, and we need to show origin of our cube. Here we create an empty object, and we interested, for example, let's first of all check this place above. Equal to 0.5, and I will name it as full blue region and move it to the base region. So we will see the transform coordinates of the cube origin. And in the MATLAB we need to write similar things. Here it's shown that for x for y we need to look for the z value, is this one. Here we need to write minus. Here for the x we need to write for the x, so they correspond to each other. X corresponds to x, y is z, and z is y, so this value. Next, once we show these coordinates to the MATLAB, we need to use function translate. It's also robotic toolbox function. So here we put our coordinates, and further with it the inverse kinematics of the robot will be calculated. So it will provide how we need to change our joints in order to approach this point. And here it's shown that rotation around x is equal to 180. It means that the robotic arm will be vertical to this cube. Vertical means that he is a cube and we approach it this way, like vertical way, not bend the robotic arm. Next, so here is the inverse kinematic calculation, and next is the initial robot position. So next we calculate the trajectory from our initial position to our cube, and next we create the function here. So we use function data, so during every step we send the data, we update the robot position. For example, what this function data is doing, so we have the trajectory, we have the step, so every step we send angle for every joint, so it moves step by step gradually. So here we can display how precise we wanna move our robot. For example, here we move it with a step equal 0.1. If here will be 0.5, it will be not precise, so we will see just sharp movements of the robot. 0.1, it means that the robot will move more gradually. So what we send to the Unity, we send the trajectory, we send the grab function, and we send the step. So what we can see here. Write TCP, it's what we'll write to the TCP is print tf function. It means that these values are float variables. The last one, grab one, object is integer value. So this is the integer value, other float values, and we use some delay between these steps just in order to be able to write data correctly. Next, so in this step we approach to the cube. Let's first, next step we wanna take the cube. First of all, let's consider just the first step, just this section, how can we approach to the cube. Next, let's also take a look to the script itself. I just copied it and maybe it's needed some settings here. So what data do we get here in this file? So how can you operate with the data? So here, first of all, we delimitate some characters, this and these commas, so we get the string without these symbols. If we'll take a look to the MATLAB, here we'll see that it contains of some symbols. So first of all, we delete them. Next, we split our string, so we will have these values separate. We will have string mod robot and this float and integer values. Next, for case, in other tutorials we will have more cases. Currently we will have just mod robot case. So here we switch based on our cases. Currently we have only one case, mod robot, this case. If we will get some other string, we can also write case and another case. And next we parse some data. Here we try to parse float data for our joints. This is our joints angles. Here we need to write also for float parse. For some things it's not really necessary to write this statement, but here we will get an error because some systems they use for floating numbers comma, some points. So here we need to write invariant culture, so to get it more universal floats and float numbers with point and comma. So we obtain every angle joint, then we modify our robot respectively. So we create function here for and using these values. We are interested in our game object robot1. It's this object robot1, and we modify these values with the angles we obtained from the MATLAB. Next, for gripper, we need to find animation EE. That's how I called the sphere before. I will also copy this component and rename the sphere. And then we're interested in collider test object. So I will find my sphere, and we're interested in this collider test object. I will name it as animation EE. So what we do inside this function, we modify angles and grab function based on these variables. Let's try to test the first section now. Section number 1, first level. And so I will run this Unity project. Also, it shouldn't be updated this way. Let me see. How did I make it before? Oh, here should be another component. So here should be 0 value. So I'll create another J5 component. So it won't rotate J5. Here 0. Here we touch it. Here we have 0. You have 90. Robot. Also change this one, very important. So now we have this object attached. So now if I run it, it won't change its position. Next, let's try to run the section number 1. Here we need to just approach to this cube. Try to run this section, so we approach to our cube as for this section. Here we wrote before gripping point equal to end effector, so we approach with the end effector point. Let's try to write gripper point equal not to the end effector but to this point and run again. Now we need to approach by the object. And here we approach with some error y. Let's try to find the end effector object. Probably because origin of the blue cube, origin of the robot, and effector not here, and effector. Oh yeah, let's check this origins again. This one, this one, this one. Also it shifted a bit. I remember what the thing here. For example, if we take a look, yes, I forgot about this thing, sorry about that. So if we will take a look to our joint 2 and joint 3. So currently if we start our robot, currently I will disable the gripper, and now if I will run the section 1, okay, it's lost some data. Let's try to run together. So the robot position with some error, so it shouldn't locate the end effector. End effector should be located above the cube. Now we entered the cube. So then some problem with the joints we will fix now. I forgot about this thing about last video, for the last video, so we will make this correction now and everything will be fine with our robot. So how to make these corrections? So if we'll take a look to our joint 4 and joint 3, and if we'll take a look to this file, we will see that this joint point and this joint point, they should be aligned. They should be located along the same axis. So what we have here, it's not really correct because they are not aligned. For example, if I will create empty object here and move it to the joint 2, zero here, we will see that these two, they have some displacement, so we need to correct it. Before I calculated that we need to make here incline equal to 5 degrees. So I calculated the tangent of this triangular and found that value equal to 5 will correspond to this displacement. So we need to rotate here to the value of 5 degrees. Here and here. And again, here we need to have the 0 value, so again we need to create a new region. Create empty. Name it as J2. Here write 0. Touch it here. So here we have 0. Here we also need to have 0. Create empty. Join 3. Here 0 first. Attach here. So check everything. We need to have 0 points everywhere, and we need to update the robot file. As for joint number 2, should be this file, and joint number 3 with this file. Joint 3. So that's all. Next we can compare these regions again. So now we will see that they are aligned with each other. Create empty. Here will be joint 2. Here will be joint 3. Here will be joint 5. Next, and the factor. Next, the grip point. Gripper. And also I will locate them here. Gripper region and the factor region. So for comparing purpose. Next again, let's check our position with the Matlab. Join to this value. Join 3 is equal to 32. Next, this value. let's try to run first and then check these other values. Do we need to correct them or not? Run section. Yes, we need to correct those origins as well. So Matlab and check other origin J5. Here we need to have 2.5 1.4.5. Next, the end effector. .55. Let's leave this way. Gripping point 194. Let's leave this way and try to run again. We see now that position is a bit above, but again, still we have some error here. Again, let's check one more time all of the regions. Five different here. No problem. I move here. I move here. Probably because of the rotations as well. Let's try to make it again. So probably the problem was with the rotations before. So probably I found an error. So let's check one more time. We have base origin here. We have join to origin here. I create empty object. Move it here. Name it as J2. Next, J3 origin. Create empty. Move here. Here I need to install 0 degrees. J3. Next, I need a J5 origin. Create empty. Move it here. Here you will see the value 735. So this is our value, what we're interested in. So also rotations influenced our values in Unity. Next, here we have EE origin, so we copy it here. And we have grip origin, so we copy it also here. And next, check with Matlab everything again. Our join 2, here we need to have this value. Next, another joint 0.32, joint number 5, 7, 3, 5, also -25 here. Next one, here region 0.56 we can write, and grid by origin equal to -1978. So if we now use gripping point equal to the end effector, so we will approach end effector with a cube. Let's try to run this section. Run section. Okay. Start Unity. Run section. And we will see that the end effector approach to our cube in a precise way. So we will check the end effector origin here. If we will move it to the base origin, we will see similar coordinates to our cube. Next, for example, if we change gripper point to this point, not to the end effector, we will see how the gripper will approach to our cube. So we run this section. Here it approached, but it pushed our cube to the downside because I didn't select the isTriggered object. So animation E, here I need to activate isTriggered so it won't push my object. That's what I wanted to show in the beginning of the video. So if we have collider here, and if it will interact with another collider, so it will push the object. So in order to enter the object, we need to use isTriggered here. So I will activate this element here, run the Unity again, start the script. Here we'll see that it was entered our cube. During the next section we can grab our cube. So here we take object, we set the grab component equal to 1, which will grab our object, and we again using function funcData. Here we use the previous robot position, so we finished position of our robot, but it was incremented in the previous step, so we need to use b-1 to use the last position of our robot. So let's run just this section number 2, so we take the object. So run this section, it will grab our object. So it was grabbed. Here we can see that parent object of our cube has changed, and during the next program step we can send our robot to initial position. Grab equal to 2, it means that we do nothing as we already grabbed our object. B equal to 1, so we start to use, we reset our counter, so we'll move back to our initial position. So this means that we use reverse writing for trajectory. From this cube pose we move to our initial position with a step and send data. Let's run just part for sending our robot back to initial position. So run just this section, so we moved back to initial position. And last program code is to release our object. So we send grep equal to 0, again b minus to 1 because we need to use the last position. Here we, during the last step, increment our counter. Here we need to delete this one, so we use the last position, just release the object grep equal to 1. So run this section. Here we will see the result of the operation. And for example, let's see how this code will look like together. Let's probably, I will copy all of these files to our project. Show and explore. And next, upload them to the server. Here's our Matlab project. So I will close these functions and open from the Matlab project. Here you will need to change location, change folder to this one. So here you have similar function. This function which writes data to TCP, so this is used for sending data. This is used for initialization, and here's our program. So let's try to play all together and see how it looks like. So we started. Open Matlab, run, and see that it will take the object, pick it up, and release the object. So that's all for this video. It was maybe a bit confusing, but sorry for that. Just follow its steps and you will have the similar result.